students, and welcome back to Study Room. So, continuing on our chapters about sources of energy, today we're going to do conventional sources of energy and we're going to do its first part. So, if you remember, I have used the word by convention or convention says a lot of time. What does that actually mean? Do you know what it actually means? Convention basically means that what is accepted or what has been going on for a long time or what is the usual or what is the more common. That is what convention basically means. So when we did the sign convention, we were talking about the signs in case of mirrors and lenses that are usually used or conventionally used. So conventional sources of energy, that should give you an idea about what they are. Okay, so I'll leave you with that thought and I'm going to tell you now. Okay. So, the conventional sources of energy such as natural gas, oil, coal are all conventional sources of energy. They are finite, but they still hold a majority of the share in the energy market. So, these conventional sources of energy are the sources of energy which have been in use for a longer period of time. That means the generations before us, all those generations have used these sources of energies like coal, petroleum, natural gas. All of these sources have been used a lot. So these are conventional sources. They have been in use or they were the common sources of energy. Why? Because at that time they were readily available and they were relatively cheaper. Okay. They are finite. What does finite mean? Finite means that there is only a specific amount of the conventional sources of energy. So they are not available in an infinite amount. That means that if we keep using them and just keep using and going and going and going, then one day they would be absolutely finished, right? So there would be absolutely no coal, petroleum or natural gas left if we continuously keep using them without trying to switch to any other source of energy. Okay, but they still hold a majority of share in the energy market. Why? Because obviously because they have been in use for so long, so they just can't go out of use so quickly because people are very dependent on it and still they are very cheap also. Okay, great. So the share of energy sources used in India, look at this. Just look at how much of our energy needs is met by coal. And coal is one of the most polluting sources of energy. So that means that it is actually having a very bad impact on the environment, but we still use it, right? Petroleum and natural gas, a big chunk, but comparatively smaller. Hydropower is right now a bigger chunk compared to petroleum and natural gas because it is also a very clean source of energy. It is very good for us also. Then nuclear is a very comparatively, it is a newer source of energy which is still being explored. So it is not as much, it doesn't take as much energy. Like we don't satisfy a lot of our energy needs using nuclear energy. And wind energy is also a very small part. Why nuclear energy is less and why hydro energy is also comparatively less than coal, all of that we're going to do as we study the non-conventional sources of energy too. Okay, great. So fossil fuels. So what are fossil fuels? Fossil fuels are basically when like old organisms that lived like millions of years ago, they go down to the bottom of the sea, like the sea bed, and more sand gets deposited on them, and this process keeps going on. Or even on land, more sand gets deposited on them. So at one point, the temperature, because they are so deep inside the earth, their temperature increases to a very high amount and they basically get converted into these fuels which are known as fossil fuels. So these are actually dead organisms from millions of years ago. So here in your PPT says that fossil fuels are non-renewable. Non-renewable. Now what does non-renewable mean? Non basically means something that can't happen. It's like a no to anything that we are saying here. As we are saying renewable, what does renewable mean? Renew. That means it can be made new again. So what does renewable mean? A source which is renewable means that it can be made again and again. It can go on continuously. Non-renewable means that it can't go on continuously, being made again and again. So fossil fuels, why do we call them non-renewable? Because they take millions of years to form also. Like I said, right, an organism dies, then layers and layers and layers of earth and sand keeps getting deposited on them, then they get to a high heat, then they slowly turn into fossil fuel. So it's a millions of years long process. So that is why we call them non-renewable, because we can't wait for millions of years for this fuel to be formed, right? So it's almost like non-renewable for us, even though it is getting renewed. A million years is not a short time, so it is, we call it non-renewable. So non-renewable means that it can't be replenished at a fast rate, or we say that it can't be replenished. Okay, so fossil fuels like coal are sources of energy which are non-renewable. That means they can't be renewed again and again, formed with millions of years ago, and there are only limited reserves, which means that if we keep using these reserves continuously without letting them replenish, if we use a small amount and then leave it and then let it replenish after like a million years, then we won't have a problem. But what is happening right now is humankind is just going on utilizing these non-renewable sources of energy, not giving them time to get replenished, and that is why we have an energy crisis. So we need to conserve them. That is the whole energy crisis. That is what it is about. Okay, so here you can see that the trees are killed by acid rain. Okay, so the next topic is thermal power plant. So what exactly is a thermal power plant? Thermal basically means anything to do with heat. So in thermal power plants, conventional source of energy like coal is used to heat up, like boil huge amounts of water, and then that water, the steam from the water, is sent through pipes to produce electricity. So like your PPT says that in thermal power plants, large amounts of fossil fuels like coal are burned to heat up water to produce steam, which further runs the turbines and generates electricity. So why don't we just use coal straight away? Because it is much more difficult to transport coal and petroleum and other fossil fuels, and it is much easier to transport steam, right? So steam can easily be transported through a pipe, but coal is so bulky, it is so heavy, you will need like so many trucks to take it from one place to the other, but steam can simply be transported through a pipeline, right? So that is why we use steam as a source of energy, but we are using the coal to burn the coal to boil the water. So that is why it is a traditional source of energy or conventional source of energy, and it is still bad for the environment, because even though steam is the final energy that we are using, the coal is still being burnt, and that is still bad for the environment. Okay, so here it shows a demonstration of the thermoelectric production, that is what exactly goes on in the thermal power plant. So this, from here we are providing heat, like this is what the coal does. The coal is burnt and the heat is provided. A pressure cooker is an example for the water in the thermal power plant that is boiled. Then from the thermal power plants, like in this is actually just a life example for you, like the pressure cooker represents the thermal power plant's water that is boiled. So this is like made with things that you know in daily life. So then the steam is sent through these pipelines, and then the steam, because steam has a lot of energy too, right? After water gets boiled, it turns into steam, so it has a lot of energy too. So that is used to turn the turbines or for doing any mechanical work. Okay, then this is turned through a dynamo. A dynamo is basically any device. It's a device that can turn this mechanical work into electrical energy, and that electrical energy is finally used to light up your bulb or your appliances. So this is the path that is followed from the thermal power plant. The water is boiled using coal. The steam is taken through pipelines. It is used to run a turbine, and that energy goes into a dynamo, which finally turns into electrical energy and gives you light in your homes. So here the moving fluids, this simple turbine assembly, one moving part, a rotor blade assembly, and the moving fluid acts on the blades to spin them. So this is basically a simple diagram which is showed to simplify down what exactly goes on in a thermal power plant so that you can understand it. Okay, great. Now, a hydropower plant, it basically converts the potential energy of falling water. So, what did we learn about potential energy? We learned that potential energy is by virtue of position or by virtue of height. So, what happens in hydropower plants? You just hold water at a particular height, at a very high height. So because the height from the ground is more, the potential energy is more. That is the relation. Okay, when the height is more, the potential energy of any object is more. That is why when you fall from like the third floor, you get more hurt than if you fall from the first floor, because as you go higher and higher, your potential energy increases, and when you fall, all of that energy is going to get converted and it will hurt you even more. Okay, don't try this. So water is held at a height and it is dropped, and that is converted into electricity. How? Let's see. So here, water from a high level in the dam is carried through pipes, okay, to the turbine at the bottom. So look here, these sluice gates, this is basically, it's basically like a stopping gate for the water. So here, in this part, the water is stored. If any of you have seen any dam, you must have seen these big gigantic walls made which are holding water to one side. So this is what basically goes on inside them. So water is held at this place. Then through these sluice gates, the water is sent down here, right? And then it is used to rotate this turbine. Can you see this turbine is labeled here? Then this water, because it is coming from a height and it has some speed in it, it hits that turbine, it rotates that turbine at the bottom of the dam, right? This rotating of the turbine is then turned into your electricity, and it is used to light up your homes again. So you can see that in any case, be it thermal energy or be it hydro energy, you are using your source of energy to generate something, to move something, and that energy is then converted in your electrical energy form and it is supplied to you. Okay. So the water in the reservoir would be filled each time it rains. That is how it gets replenished. So these power lines, you can see, these are the power lines that take the electrical energy from here to your homes. Okay, great. Now the problems in construction of dams. So if you must have heard, there are a lot of disputes that go on over the building of dams. Why is that? Because, let's read in your PPT, large areas of agricultural land, human habitation and large ecosystems are sacrificed. Why? Because dams have to be built in a place where it is like far away from the main city. But it's not like people don't live there. There are people whose homes are made there, and there is a lot of green plush land there. There are a lot of trees there wherever the dam has to be built usually. So what happens? All of those trees have to be cut, and all the vegetation that is on the ground where the water is going to be filled, it is all submerged. So say if there were a few farmer families who had that land as their only source of income, so they lose that land to these big companies who come to build dams. That is why there are so many protests regarding the building of these dams, because a lot of livelihoods are ruined because of this. Okay, so this is something that you have to think about also. What is more important, the lives and livelihood and feelings of these farmers or these small people who live there, or is building dams more important because of economical and progress related things? So that is a very subjective question. You might think that progress is more important. I might think that people are more important, because if progress is for the people, then if the people are not happy, what are you going to do with the progress? It's pretty much useless, right? So you have to think in that way. But in terms of your chapter, you have to know why there is a lot of problem regarding the building of these dams, because large areas of agricultural land has to be submerged. Human habitation, people have to be rehabilitated, means they have to be removed from their homes and they have to be settled in some other places. And a lot of times these companies promise these people that we will give you a home here, we will, even though we are taking your home at this place, we are going to give you a much better home at some other place, you will receive benefits and everything, and they're just removed from their lands and forgotten. They're given nothing, no compensation for whatever was taken away from them. Okay, then the vegetation which is submerged rots under anaerobic condition. So what is anaerobic condition? When there is respiration without oxygen, because it is all covered in water. So compared to air, water has much less oxygen. So all of the agricultural land of the farmers, or the vegetation that is at the bottom of the place where the water is, like water is filled, right? So at the bottom of it, all that vegetation rots, and it gives rise to anaerobic respiration, which gives rise to large amounts of methane, which is also a greenhouse gas. So again, even though you might think, oh, hydroelectricity, we are using water, so it's a clean source, it's not polluting the environment, you're just using it to run a turbine and then electricity. But no, there is so much that actually goes behind it that you just saw. Finally, it is again releasing methane, which is a greenhouse gas, and it is harming our environment again. So what's the use of it, right? Okay, I'll leave you with that. So this was it for the conventional sources of energy, part 1. In the next video, we're going to do part 2 of it. Hello students. So let's continue with the part 2 of conventional sources of energy. So the first is biomass. So the fuels which are due to plant and animal. Bio basically means anything to do with life. So any fuel that is obtained from plants and animals is known as biomass, and how these are obtained I will just tell you in a bit. And the sources of these fuels is said to be biomass. Okay, and it is made, this figure actually shows you how it is made in like this dome shaped thing, and everything that is put in it we'll just study. Okay, so the process is this. When wood is burnt in limited supply of oxygen, that means it is not burnt in open air, it is burnt in a specific condition where the supply of oxygen is limited. Limited supply of oxygen, water and volatile materials present in it. What happens when this is burnt with limited supply of oxygen? The water and the volatile materials, that means water is the moisture part of it and the volatile materials are the materials which can evaporate faster. So all of those materials get removed and charcoal is what is left behind as the residue of that wood. Okay, this charcoal is what is left behind. Then cow dung and various plant materials, say like waste from our kitchen and stuff like that, like the residue after harvesting crops, vegetable waste from our kitchen, all of these, sewage, all of these are decomposed in the absence of oxygen to give biogas. So this is a process that you just have to remember how it happens. Okay, it is also popularly known as gobar gas because in Hindi we know that cow dung is known as gobar. So because cow dung is a very big component of it, or the starting material of it, it is also known as cow dung gas or gobar gas. Okay, now this is actually the setup for it. This is the slurry. This is the digester is basically this big part where all of the process happens of the conversion of all of these slurry and the waste from the kitchen, vegetable waste and cow dung and everything to be converted into biogas. This is where the fertilizer is. The fertilizer is basically, so this is a plus point of the biomass or the biofuel being generated, because you get a residue of fertilizer or manure, which means that you are using things that are waste to you, like cow dung, vegetable waste, kitchen waste, and you are even getting something that is useful for your crops also. You are getting manure. So that is why this is a very, very good technique. Okay. So this is covered in soil. So basically this whole setup is underground. Okay. So this is the soil and this is the gas tank. It can be underground or it can be above the ground also. This is filled with soil. And it is basically let to decompose all of the gas, all of the slurry, all of the dung, cow dung and all of the vegetable waste is let to decompose, and what we get as a byproduct of it is manure. And this is the gas outlet from where the natural gas or the biogas actually is taken out, and it is directly used in the homes of the people around it. Okay. Great. The advantages of biogas. This is very, very important because it is asked a lot of times, like why is biogas even used? What is its advantage? So it is an excellent fuel because as it contains up to 75% methane. Now this is not like the methane we were talking about in like hydroelectricity, that methane is released. This is made up of, when we generate biogas, it generates 75% methane, but it is used up in the cooking and in other processes. So it gives a lot of energy to basically do all the work that you need to. That is why it is a very good fuel. It burns without smoke. It leaves no residue. And like ash, after we burn wood, what do we get? We get the ash. After we burn paper, we get ash. After wood, we get charcoal. And after coal, we get the black residue from it. So biogas is a clean gas, so it does not leave any residue. It is heating capacity, it's very high because it contains 75% methane, so it has a lot of heat capacity. It is also used for lighting. The slurry left behind is removed periodically and is used as excellent manure. This I already told you that it is even more important in rural areas because the leftover or the byproduct, which is usually useless for us, is actually useful for them because they can use it for their crops also, which is rich in nitrogen and phosphorus. Okay, great. Now, wind energy. To generate electricity, the rotatory motion, if you have seen these windmills, they look like this. They look something like this. Huge fans, right? So these windmills are basically used to generate electricity. How? The rotary motion or the rotatory motion or the rotating motion of the windmills, like our fan rotates, that motion is used to turn the turbine and which is used to generate electricity. So this is something that you will find in common, that a turbine is rotated and something happens and electricity is generated. Okay, so that is something in common to all the sources of energy. Okay, so this rotatory motion of the windmill is used to turn a turbine and which is used to generate electricity. So harnessing wind energy, Denmark is known as the country of wind because 25%. It does not seem like a lot saying it out loud like this, but 25% is a huge amount for a country, especially when it is a source of energy like wind because it is not polluting the environment. As the electricity needs are 25% of the electricity needs are generated through windmills. In terms of total output, Germany is the leader, while India is ranked 5th in harnessing wind energy for production of electricity. The largest wind energy farm in India is near Kanyakumari in Tamil Nadu, and it generates 380 megawatts of electricity. So these are some facts that you should remember and keep in your mind. Okay. Now, what are the disadvantages? If wind energy or generation of electricity using windmills is so easy, then why doesn't the whole country use it? These are the reasons why. So, wind energy farms can be established only at those places where wind blows greater for a greater part of the year. So, in a place like Delhi or somewhere you live, do you see wind blowing like 24/7? Is it super windy 24/7? No, right? It usually gets windy for like 2 minutes in a day or like 2-3 times in a day. You just see the leaves rustling very beautifully or like the wind blowing with a lot of sound, but it's not something that happens throughout the day, throughout the year, right? So if we set up windmills in a place where not much air or wind blows, would it be useful for us? No, right? You would spend so much money, so much manpower, so much time in setting up the windmills, and you would not get the energy that you actually want. So that's just a waste of everything, right? So that is one big drawback of wind energy, to find a place like this where there is a lot of wind blowing for a larger part of the year. Even if it's not 365 days in a year, even if it's a big part of the year, say like 6 months, 7 months, even if it's that much, it's still worth it, but not in a city like place like Delhi because not much wind blows here. Then it says that the wind speed should be higher than 15 kilometers per hour to maintain the required speed of the turbine. Again, another set on or another benchmark for the wind. Only if the wind is higher than this would the energy generated from this method be useful for us, and that is why not every place can be a place that windmills can be set up in. Then establishment of wind energy farms requires large area of land and high level maintenance. For a 1 megawatt generator, the farm needed is about 2 hectares. Okay, so what does this mean? That in a city like place where there is a building at every 100 meters, you can't set up a windmill. For a windmill to be set up, you need huge areas of open land where there are no people nearby, right? So that cannot be acquired in many places in India also and in other countries also. So that is another setback of wind energy, that it can't be set up anywhere in any city or any urban area just like that. Okay, great. Now the first question says, what are the disadvantages of using fossil fuels? So again, you write it in complete point form and a complete point form by writing a sentence starting that the disadvantages of using fossil fuels are as follows. I am writing it in short, you will write it properly. The first one, that it's non-renewable. then it pollutes the environment. Then another point you can write is, if not used properly, can be very hazardous. That means they can actually harm the people that are using those fossil fuels. Also, we can write like coal mining is difficult and dangerous also. You must have heard sometimes that these many people lost their lives in a mine fire, or they got trapped in a mine and they died. So mining is not a very easy job to do. So that is why it is more important to not use fossil fuels and switch to other types of fuels. Now the next question says, what are we looking at? Why are we looking at alternate sources of energy? So again, this would be, we need more renewable sources. This is basically the opposite of what we wrote for conventional sources. Renewable, we need sources which are less polluting. Then we need sources which are non-hazardous for people and for the environment. And some points you can add on if you feel like it. Okay, great. The next question says, how has the traditional use of wind and water energy been modified for our convenience? So in this you will write, actually in older times, wind energy was used. I'm writing again in short form, you will write it in complete sentences. Wind energy was used to draw water from a well. You know that lever that you, or the big rope that you have to keep pulling to bring that bucket of water up from the well. Wind energy was used to do that, draw water from well. This was what it was used for. And it was also used to grind flour, to make the flour for our like rotis and stuff like that. That was what wind energy was actually used for. But now, then you can write, now it is used for generation of electricity. Right? Then what about water energy? Water energy was actually first used. How was it used? It was used by using waterfalls. Because in old times we didn't have this much technology or money or the manpower or the thinking power. So we just went to a place where water was naturally falling from a height, which is a waterfall. But now, what do? Now we do it manually. Now we trap water at large heights and use that to generate electricity, right? So we have moved a lot farther from our natural use and our natural ways, right? Do you think that is correct? So this chapter is also going to give you a lot of these questions which are open to discussion. So it is up to you what you want to think. You can discuss it with your friends, what they think. And this is something that you should do, that because your book is not just for like memorizing it and going and writing in the exam and getting marks. It is also to make you think more. It is also to make you better people. It is also to make you more informed students and people in the world. So this chapter is important in that way too, that it makes you think about these things that you use and you take for granted. Like you use and you take energy for granted. You leave your light on and fan on when you leave the room. You don't think about how much work is being going on or how much energy is being put into getting that energy to you. So I hope this chapter is going to make you think a lot about that too. So in the next class, we're going to start with the non-conventional sources of energy. Okay.